friends, this is Dr. Aparna Sajjan, Associate Professor in Chemistry, VPKVIT, Baramati. In this video lecture under Water Technology, we will discuss numericals, how to solve on the alkalinity of water. Before that, we should know what is alkalinity of water. It is nothing but the total amount of substances that increase the OH- concentration of water by either dissociation or by hydrolysis. So if OH- ions are increased, then water becomes alkaline. There are three different types of alkalinities. The first one is hydroxide alkalinity, which can be caused by hydroxides. The second type of alkalinity is carbonate alkalinity, which is caused by the presence of substances, carbonates. For example, magnesium carbonate. And the third type of alkalinity is bicarbonate alkalinity, which is caused by the presence of substances called bicarbonates, like calcium bicarbonate, sodium bicarbonate. So in total, there are three different types of alkalinities. One of them is bicarbonate, the other is carbonate, and the third is hydroxide alkalinity. Alkalinity is determined volumetrically by titrating water sample with acid. That means normal acid-base titration is used, and the acid-base indicators like phenolphthalein and methyl orange are also used in the titration. If water is strongly alkaline due to the presence of hydroxides, then the end point of the titration is detected by phenolphthalein indicator. If water is slightly alkaline due to the presence of bicarbonate salts, then the end point of the titration is detected by methyl orange indicator. That is the volume of acid. How much is the volume of acid that is required for methyl orange endpoint? If carbonate alkalinities are present, then half of the neutralization is detected by phenolphthalein, that is half volume of acid used up to phenolphthalein endpoint and the remaining half up to methyl orange endpoint. That means carbonate neutralization takes place in two steps. Half of it is neutralized and which is detected by phenolphthalein, and the remaining half is neutralized and which is detected by methyl orange indicator. So based on the different types of alkalinities, we have to see water contains either bicarbonate alkalinity or hydroxide alkalinity or carbonate alkalinity, or it may contain two different types of alkalinities at a time also. Taking into account V2 as the total endpoint and V1 as the phenolphthalein endpoint. V2 and V1. V1 is also the phenolphthalein endpoint, therefore it can be used as P. So in the first case, if P is 0, that means phenolphthalein endpoint is 0. The total endpoint will be only up to methyl orange endpoint. That means alkalinity is due to bicarbonate alkalinity. And the total volume of acid is calculated by taking the T, that is total, which is used for calculating the bicarbonate alkalinity. In the second case, if phenolphthalein endpoint is the total endpoint, means methyl orange endpoint is 0. In that case, the alkalinity is only due to hydroxides. And whatever the volume, total volume of acid is there, that total volume is used for the calculation of hydroxide alkalinity. In the next case, if V1 is exactly half of V2, means phenolphthalein endpoint is exactly equal to half of total endpoint. In that case, only carbonate alkalinity is present. which means that half of the volume of acid is used up to phenolphthalein endpoint and remaining half is used up to methyl orange endpoint. In that case, we can use either 2P or total volume for calculating the carbonate alkalinity. Then, if the alkalinities present are in combination, means two different types of alkalinities are present at a time. In the earlier three cases, there were separate alkalinities present in water, but in these two cases, combinations are there. If V1 is greater than half of total V2 or P is greater than half of T, means P is required more. Phenolphthalein endpoint is more than methyl orange endpoint. In that case, alkalinity is due to carbonate as well as hydroxide. The volume of acid required for hydroxide is calculated by using the formula 2P minus T, and the volume of acid required for carbonate alkalinity is calculated by using 2 into T minus P, that is 2 into total minus P. In the last case, if V1 is less than half of V2, means P is less than half of total, it indicates that phenolphthalein endpoint is less than the methyl orange endpoint. In that case, the alkalinities present are carbonate and bicarbonate, and the volume of acids calculated by using 2P for carbonate and T minus 2P, total minus 2P for bicarbonate. Then general calculation includes, after finding out the volume of acid, we have to calculate the amount of alkalinity present in water. And alkalinity is always expressed in equivalence of CaCO3. Means equivalent weight of CaCO3 is used. Molecular weight of CaCO3 is 100, and because calcium is a divalent metal, molecular weight divided by 2 will give 50. So molecular weight 100 upon 2 is 50 is the equivalent weight of CaCO3. So 1 mole of acid is equal to 1 mole equivalent of CaCO3, which comes to 1000 ml of 1N acid is equivalent to 50 grams of CaCO3. If we convert 1000 to 1, it comes to 50 divided by 1000 gram or 50 milligrams of CaCO3. So for whatever the volume of acid that is consumed during titration, for that volume of acid used standard acid, that normality, we get 50 into volume of acid into normality of acid, that is m milligrams of CaCO3. So this much alkalinity, that is m milligram of alkalinity, is present in W ml of water sample titrated. For 1 liter, what is the answer? So for 1 liter calculation, we have to use the same formula with 1000 upon volume of water titrated, and the answer will be in milligrams per liter. Earlier it was only milligrams, now it is milligrams per liter, also equal to ppm. So with all these background, let us see the numerical. 50 ml of alkaline water sample requires 9.2 ml of this normal 0.025 normal acid up to phenolphthalein endpoint and a total of 13.1 ml of acid for complete neutralization. Find the types and amounts of alkalinities in water sample. In this case, methyl orange endpoint is not given. Directly phenolphthalein endpoint and total endpoints are given. So methyl orange endpoint will be 13.1 minus 9.2. And we know that all kinds of alkalinities are expressed in terms of CaCO3 equivalents as parts per million. Therefore, using the formulas, methyl orange endpoint is T minus P. total minus phenolphthalein, that is 3.9, and half of the total titration volume is 6.55, that is 13.1 divided by 2 is 6.55. Therefore, the condition satisfied is P is greater than half of total, means 9.2 is greater than 6.55. And in that condition, the types of alkalinities are hydroxide and carbonate. So this is the first step that you have to mention. Find the types. Means the condition satisfied is this. Therefore, under this condition, these two types of alkalinities are present in water, that is hydroxide and carbonate. Next is calculation using the standard equation. 1 mole of acid is equal to 1 mole equivalent of CaCO3, that comes to 1000 ml 1 in acid is equivalent to 50 grams of CaCO3. For 1 ml of acid, 50 milligrams of CaCO3. So Vml of this normal acid is equivalent to V into 0.025 into 50, which is equal to A milligrams of CaCO3. Now let us calculate the individual alkalinities. We know the volume of acid under the condition P greater than half of total. For hydroxide alkalinity, it is 2P minus T. The answer is 5.3. So volume of acid 5.3, normality of acid 0.025, equivalent weight of CaCO3 50 into liter conversion 1000 upon volume of water titrated. The answer is 132.5 milligrams per liter. Next is calculation of carbonate alkalinity. So for that, volume of acid is 2 into T minus P. The answer comes to 7.8. So this much volume of acid was used for carbonate neutralization. 7.8 into normality 0.025, 50 equivalent weight and 1000 upon volume of water titrated. The answer comes to 195 milligrams per liter. So lastly, you have to mention the types of alkalinities present: hydroxide 132.5 and carbonate 195 milligram per liter. Let us take the next numerical. 50 ml of alkaline water sample, means titrated volume of water is 50. Requires 5.2 ml of N by 50 HCl up to phenolphthalein endpoint. N by 50 means 1 by 50. And total volume of acid is 13.4 ml. For complete neutralization, find the types and amounts of alkalinities. So once again, we know that volume of water sample is 50. Normality of acid comes to 0.02. Phenolphthalein endpoint given is 5.2 and the total endpoint is 13.4. So first we have to find out condition satisfied, that is P is less than half of total, that is 5.2 is less than half of 13.4. Half of 13.4 is 6.7, therefore 5.2 is less than 6.7. So water sample is alkaline due to, in this condition, the water sample contains alkalinities bicarbonate and carbonate. And again, using the standard equation, we have to do the further calculations. Alkalinity due to bicarbonate. For that, we have to calculate the volume of HCl. T minus 2P is the formula used. And after solving this, we get 3 ml of acid. That means 3 ml of acid, HCl, was used for neutralizing bicarbonate alkalinity. So 3 into 0.02 normality into 50 equivalent weight into 1000 upon volume of water. And after solving, we get the answer 60 milligram per liter. Next, we have to calculate the amount of carbonate alkalinity. For that, volume of HCl consumed is either total volume or 2P. So 2 into P is 5.2, 10.4 ml. 10.4 ml of acid was used for neutralizing carbonate alkalinity. So the given total volume is 13.4 ml. So out of 13.4, 3 ml was used for bicarbonate alkalinity neutralization and 10.4 ml of acid was used for carbonate alkalinity neutralization. So this is the calculation: 10.4 into 0.02, 50 into 1000 upon 50. The answer comes to 208. And again mention the different types of alkalinities with their amount at the end. Next, let us take another type. 100 ml of water sample on titration, means volume of water titrated is 100. With N by 50 HCl required 17.5 ml for phenolphthalein endpoint, and when methyl orange was added to the same, pink color developed. Describe the type and amount of alkalinity present in the water. That means after adding methyl orange endpoint, we don't get the required color for titration. The end color is obtained. Means methyl orange endpoint is 0. Whatever the acid was used, it was only up to phenolphthalein endpoint. So normality of acid given is 0.02. Phenolphthalein endpoint V1 or P is 17.5 ml and the total burette reading is also 17.5 because methyl orange endpoint given is 0. Therefore, condition satisfied is P is equal to T. Phenolphthalein endpoint is equal to total endpoint. And hence, water will contain only hydroxide alkalinity. Let us see the calculations. Using the standard equation, 1000 ml 1N acid is equivalent to 50 grams of CaCO3. 1 ml of 1N acid is equivalent to 50 milligrams of CaCO3. Therefore, V ml of 0.02N acid is equivalent to how many milligrams? That is 50 into V into 0.02. Calculation is very simple. We have to calculate only one type of alkalinity here using whatever the volume that is given, total. So, alkalinity due to hydroxide is volume of acid, normality of acid, equivalent weight into 1000 upon volume of water titrated. This time it is 100 given, therefore 100. And the answer is 175. So, lastly, hydroxide alkalinity present, it is 175 milligrams per liter. Next is another case. Water sample is not alkaline to phenolphthalein indicator, which means that clearly it is given P is 0. However, 100 ml of same sample on titration with 0.02N acid, H2SO4 requires 14.5 ml of acid to get the endpoint using methyl orange. Identify the type and amount of alkalinity. So here again only one type of alkalinity is present because phenolphthalein endpoint is 0 and whatever the endpoint is there, it is methyl orange and it is also the total. So volume of water sample 100, normality of acid given is 0.02, P is 0, MO is 14.5 and it is also total. Condition satisfied is MO is the total and therefore only bicarbonate alkalinity is present in water. So let us see the calculations. Same calculations are used. 1 mole of acid is equal to 1 mole equivalent of CaCO3. So alkalinity due to bicarbonate is volume total 14.5, which is used up to methyl orange endpoint, 0.02 normality, 50 equivalent weight, and 1000 upon 100. That comes to 145. Next and the last condition, 100 ml of alkaline water sample requires 5.4 ml of N by 50 HCl up to phenolphthalein endpoint and another 5.4 ml of acid for methyl orange endpoint. See here, 5.4 is P and 5.4 is MO. Means P and MO are equal. Find the types and amounts of alkalinities present in water. So write down the given values. Phenolphthalein and methyl orange both are 5.4. Total endpoint will be 10.8. 5.4 plus 5.4. The condition satisfied is P is equal to half of total. 5.4 is equal to half of 10.8. Therefore, water sample will contain only carbonate alkalinity. And the same calculation procedure is used. For 1 ml of 1N acid, 50 milligrams of CaCO3. For VmL of 0.02N acid, what is the milligram of CaCO3? That is 50 into V into 0.02. Now, carbonate alkalinity is calculated by using the volume of acid, total volume of acid, or 2P. Twice P is also 10.8. 2P or T is 10.8 into normality into equivalent weight into 1000 upon volume of water titrated. So after calculation, the answer is 108 milligrams per liter. So lastly mention the type and its amount. So this is how we have to solve the different numericals on alkalinity on 5 conditions. First condition is P0, second condition is MO0, third condition is P exactly equal to half of total, fourth condition P greater than half of total, and the last condition P less than half of total. So this is the end of this video lecture. Thank you.